Assalamu alaikum. I'm Asma Mushtaq from the Double Vibes, and in this tutorial, we are going to evaluate how much time a certain program takes in the PIC microcontroller. First, we will evaluate it manually, and then we will verify our results for the particular program on the MPLAB software as well. And we will see how the particular delay routine introduces a certain amount of the delay required in it. All right. So, assuming that the frequency, the crystal oscillator is having the frequency equal to 4 megahertz, fine, and we are basically interested how much time a single instruction is taking in the PIC microcontroller. So if the frequency is equal to 4 megahertz, we know that one machine cycle is equal to 4 clock periods. So basically we want to see how much one clock period is equal to 1. So one clock period is equal to 1, or whatever the frequency it is, it will be divided by 4. Fine. So we will divide 4 megahertz by 4, which will give us 1 megahertz. Okay. And then finally, we will get the 1 clock period time. So 1 clock period is actually equal to, since t is equal to 1 divided by the reciprocal of the frequencies, so that is equal to 1 microsecond. Fine. So this is basically the instruction cycle time for this particular frequency. All right. Now we know that if one instruction is taking one machine cycle, it means it will overall take 1 microsecond in its execution. Fine. Now let's evaluate the total time this program is taking. But before that, you must have the clear idea of, in this program, one machine machine cycles required for each instruction are already given, and we will evaluate the total time will be equal to total number of machine cycles into instruction instruction cycle time, which is equal to 1 microsecond in this case. Fine. Okay. Now, looking at that, we will start evaluating the time. Fine. So the first instruction is taking one machine cycle. I'll just write it separately. 1 plus. Then second instruction is also the move instruction. It is taking the one machine cycle. So 1 plus. Then we are calling the delay routine. So this takes two machine cycles. Fine. So let me write two separately over here. Then once the delay routine is called, the control is transferred over here. And in that routine, we can see that the reg register, which is actually acting my reg register, or my register is acting as a count register, and the count value is equal to 05 hex, which is also equal to 5 in the decimal. So basically, we are going to perform the looping for 5 times. Fine. When you will come to the delay routine, let's just first evaluate how many machine cycles are over here. So you can count them. They are basically equal to 1, 2, 3, 4, 5, 6, 7, 8, and 9. So overall 9 machine cycles are here. But only how many of them are being repeated? So if you look over here, we are actually branching through the label again. Okay. And in the again label, we can count the machine cycles. They are 1, 2, 3, 4, 5, and 6. So overall 6 machine cycles are being repeated 5 times, which is equal to 30. Okay. And then 1, 2, and 3 plus 3. So overall the delay routine is having 33 machine cycles. So I will just add 30 3 in this case. Fine. Then coming back to the next flow, once the delay routine ends, the control is transferred to the next location from where it was actually shifted. So we will come back over here. So 1 plus 1. Then this is also one cycle instruction. So 1. Then again we are calling a delay routine. So plus 2 for the call routine and then plus 33 for overall the delay routine. Okay. Then the go to instruction takes 2 machine cycles. Fine. Let's just count the overall machine cycles this program is taking. So overall this count is equal to 76. Okay. Once we actually move the value 55 hex into port B and call the delay, then till then we have the machine cycles equal to this, which is equal to 33, 34, 35, 36 and 37. Okay. And when we move the value 0 AA hex into the port B, it takes the time 33, 34, 35, 36, 37, 38 and 39. Okay. And overall in this way 76 cycles are actually being consumed, and we will see that the total delay is equal to 37 plus 39. Let's just check, is equal to 76. Okay. So 76 microseconds this program is actually taking. Now let's just verify the same result on the MPLAB software. In the MPLAB software, what you need to do, you will go to the debugger, and from here you will go to the settings first of all, and here you can set the frequency of the crystal that is actually attached with the PIC microcontroller. Right now